Yay.
So
Yeah.
aren't they putting them in and you're drawing after? Wouldn't that be keys? I don't think all these guys have been to the booth yet, right? I don't know, maybe.
Brendan O'Connor.
Maybe I drank one already. I'm not sure.
Fucking Brendan's not here either. I'll just keep drawing. Jeannie Brown. Jerry Brown.
Come on.
Yeah. Jerry.
All right.
Write more legibly next time, Jerry.
Absolutely.
What?
I don't have to write. It's a script.
All right. We'll go ahead and get started. Thank you guys for coming out. I appreciate it. I'm going to fly through some of the content here. This was originally a larger talk, so I'm going to try to condense it and cover as much of the material as we can. Quick slide about me. My name is Royce Davis. I'm a pen tester. Work for a company called Accuvant. It's pretty sweet. I co-founded a website called pentestgeek.com, and I also wrote a tool called Jigsaw. So the talk is called Owning Computers Without Shell Access. What we want to talk about is effectively some reasons why I think uploading a binary or uploading shells to the target may not be the best idea, at least in some cases. Go over some techniques that I kind of put together to avoid uploading shells and still achieving some of the same means of network compromise. And then really kind of the meat and potatoes of the talk is to focus on some Metasploit modules that I put together to help achieve some of this functionality. Some of them are already in the framework, so you guys can go out and get them already. Others you'll have to get from my GitHub page, so I'll make sure that there's links. So just to kind of fly on and just kind of give you guys a little bit of background information, this talk is very centric towards pen testers. So any of you guys have been in the situation where you popped a box through some vulnerability, MSO8067, for example, everybody's favorite. You get a local admin hash, and you pass that across the network, and it gets you almost everywhere. Next thing you start doing is probably pop up maybe the Metasploit PSExec module, which is a favorite as well, and that unfortunately gets stopped by the antivirus. So any advanced or motivated attacker, this isn't going to stop them dead in their tracks. But this is an issue that can be a pain. So one of the kind of first really good solutions to this was a tool called SMBexec. It was created by a colleague of mine, Eric Milam. And it's currently being developed and getting a huge makeover by Thomas McCarthy, Brandon McCann, and Eric as well. But kind of the original functionality about SMBexec was just upload a custom binary, which of course you can do that in Metasploit now as well. But the custom binary, you could obfuscate it, do whatever you want with it. You could bypass antivirus and get your shells that way. So this was really cool, and this was a good solution. But I think that the solution to the initial problem hasn't gone away. Is that we're still uploading a binary to our target. So some reasons why I think that that's not necessarily a good idea. Obviously, the number one reason is binary shell signatures. Your binary payload contains assembly language machine instructions. Antivirus vendors and intrusion detection prevention systems can flag these signatures, catalog them as malicious, and they can stop your payload from executing. So that's a huge reason to avoid this. Obfuscating your payload, it doesn't solve the issue. It doesn't remove the signature from the binary, it just changes it. So this kind of creates a cat and mouse kind of back and forth game where you're encoding your payload. It bypasses antivirus today, tomorrow it doesn't. I've been on an engagement where the client had a really robust system that actually would flag on my payload after I'd pop a couple shells, and I'd have to rebuild a new one. So this process can be kind of tedious. Also, shells can leave, they can die and basically not leave us any way to get back into the system if we didn't create a backdoor account or something of that nature. And lastly, shells oftentimes leave remnants of themselves. Even a robust shell like the Meterpreter, which is designed and wonderful to live only in memory and kind of kill itself and clean up after itself afterwards if there's some type of network connectivity or an outage that happens before those processes can finish, there are sometimes remnants and traces left over on your target system. And if you're doing any type of red team engagement where being stealthy and remaining undetected is part of the engagement, uploading a shell could, stop you right there. So I think there's a lot of reasons to avoid it. I'm not saying never do it, but what I want to do is figure out if there's some ways that we could achieve the same level of compromise that we're hoping to gain with that shell, maybe with using some functionality that's already there, something that we don't have to upload to the target. So what are the reasons we upload a shell? We could talk all day about those reasons, but the two that I want to cover that I think are really important and that we focus a lot of the time, especially as pen testers, number one, command execution. We want to interact with the operating system. We want to send commands so that we can do a number of things, create users and look for, sensitive information and documents and upload files, et cetera, et cetera. And the other thing that I want to talk about are just grabbing hashes. Local and domain cache password hashes are a very integral part of of a pen test. And luckily, I think at least just these two, we can leverage tools that already exist, kind of native Windows functionality to do this. So what we're talking about essentially is RPC, or remote procedure calls, that are baked into Windows. Essentially, if you have local administrator access, which of course you would need to do psexec, you can bind really to any API that you know the UUID for it, and then you can execute Windows commands. So there's some modules in Metasploit that are already doing this, and what I want to see, and kind of the whole purpose of the talk, is to kind of alter our mindset so that more developers are building tools that take advantage of this functionality. So the psexec module, the exploit module, the original one that H.D. Moore put together, that's kind of what the talk is going to focus on, and that's where my modules that I created kind of stemmed from. So essentially, if you've never looked at psexec, the inner workings, it's pretty simple. It binds to the Service Control Manager RPC handler, and then it executes a series of Windows functions and API calls that are in this library. So uploads a binary to the target, creates a service, then you get your shell, deletes the service, cleans up after itself. It works very, very well. But that initial piece of uploading the binary shell to the target, that piece is what can potentially stop psexec, or what causes the antivirus to flag itself. So if we want to see exactly what psexec is doing after it's bound to the handler, we can take a look at the source code, and we can see sequentially which Windows functions are being called just by looking for or grepping for the dcerpc.call method. This is a method that's part of the Metasploit dcerpc library. It takes two parameters. The first parameter is just the opcode representation of the Windows function that you want to call, and then the next is the stub data, which is basically the parameters that you want to pass to that function wrapped in an NDR format. So we can see very plainly, psexec, first thing it does, makes a call to OpenSC Manager. It then creates a service. It passes the service handler back and closes the service handler. It then opens that service that it created, starts the service, deletes the service, and then closes the service handler. So this is very nice and neat, cleans up after itself. It's very, very great. But again, uploading that binary shell to the target. We can see here in the source code, the line that I highlighted here, we can see a variable called file_location. And HD put a nice handy comment there for us, binary path. That is nothing more than the path to the file that we uploaded to the target. This is what's getting flagged by AV. So we can cross-reference this with the kind of definition of the function by Microsoft, and I apologize if you guys can't see the slide, but essentially this is what all the parameters that the create service function accepts, and we can see the parameter LP binary path name. That's where we're passing that binary. That's essentially the service that we're going to start. So if we dig a little bit deeper into the MSDN documentation, we can see a couple things about this function. First and foremost, or this parameter, it requires a binary path. It can exist on the target. It can exist on a remote system. So there's some interesting modifications that could potentially be made there for creative uses if you think of something. Also, importantly to me, and the modules that I put together, is that it can actually take parameters. So we don't just upload a binary and start a service. We can send specific parameters to that service and make it act in a certain way after it starts. So how this probably works in the default psexec module, and what you've seen before, is something like C drive and then like 16 randomly generated characters in the .exe file. That's probably an interpreter payload. This is what's getting stopped. So the way that I think we can get around this is if we can target a binary that already exists on the target, one that's not going to get flagged, one that's trusted and allowed to execute, and then potentially achieve some of those code execution and hash grabbing functionalities that we talked about in the beginning. So instead of just spawning this random.exe, we may have something kind of long and convoluted that looks similar to the full path to cmd.exe. We give the /c parameter, which the cmd.exe has a /c parameter which says execute this Windows command, whatever you want to do. So we could do, for our command, we could do echo some Windows command that we want, output it to a text file, and then output that to a batch file, and then use ampersand to launch cmd.exe again to execute the batch file. So now we've achieved code execution. We don't have to upload any binaries to the target. Yes, we do write out to a text file and a batch file. Some people have commented that that may be defeating the purpose, but I always say to that, this is ASCII data. I mean, an antivirus is not going to open a text file and read a string that says, I'm hacking the network, and call the system administrator. They're just not going to care. I did have one of my colleagues point out to me that he has seen an antivirus flag on the randomly generated name itself. So you can just go into the code and just change it, name it something friendly like Notepad or something, and it'll bypass it. So the way that I went about doing that was taking a look at the original psexec code in the exploit module and just copying and pasting it into a function and just editing it very slightly to do what I needed to do. And then I created a bunch of modules, I submitted them in Metasploit, and they said, hey, we should really do a mix-in rather than just copying and pasting all the, all the codes into the different modules. And that was a really good idea. So I went through that process and I did create the psexec.rb mix-in. So that's in Metasploit right now. And that basically introduces a couple methods that we can call. The main one is psexec, which accepts a Windows command, but it has to be passed in a certain format, which is the full path to cmd.exe. You can grab that from the Windows Global Environmental Variable comspec, and then, or comspec, I can't remember what it's called offhand. And then we give it /c, and then the parameter, whatever Windows command that we want to execute. So we'll run our command, our output will be stored in a text file. We then use a method in the psexec mixin called smb read file, which will just grab the output from that text file, and then we clean up after ourselves. So for the most part, this is a pretty good way to achieve code execution and leave the state of our target system as it was, and avoid antivirus at the same time. So I think if this is all we're doing already, I think that's pretty cool. So I'm not going to demo the module just yet. There's a couple other things that I want to talk about, and I'm going to try to fly through this and then leave some time to do the demos at the end. But just to kind of talk about some of the uses of the psexec command module, this is in Metasploit as well. So if you haven't taken a look at this, it's very useful on a pen test. Main reason is that it's an auxiliary module and it's threaded. So you could run a single Windows command on 1,000 systems in about 2 minutes, maybe 5 minutes. So some of the uses I like to do right away is I like to run the qwinsta command and just run that on the whole domain that I have access to, and then I get a list of all the users and where they're logged into. Cross-reference that with the list of domain admin users, and boom, I know exactly where the domain admins are, and I know which box to target. So if that's all you do with this, at least for me in my pen test, this has become much more efficient versus before. You'd get interpreter on 100 systems, you'd go into each one, list the processes, is there a domain admin user logged in? No, go to the next one, so on and so forth. And of course, you could write scripts to do that for you, but I think this is cleaner. So we'll talk about that and we'll demo that in a minute. So the next piece that we talked about was acquiring the password hashes. So the current methods for doing this, which are great by the way, you can use a Meterpreter post module, the hash dump, the smart hash dump module that Carlos wrote. These are great, or you can upload an exe binary like pwdump or fgdump, and you can get the hashes that way. And we've been doing this for a very, very long time. This is a very, very effective way to gain these hashes. Problem is either we're uploading a binary to the target that could be flagged as malicious, or in the case of a post module, we need to interact with the live registry and we need to extract certain keys from the LSA key so that we can decrypt the DES and MD5 SIDs to usernames and get the password hashes. And this process can actually be flagged by any antivirus or IDS that has heuristic capabilities. And I've seen it happen where this is stopped. So I think a more effective solution would be if we could get a copy of the registry hives and download them to our attacking machine. We could then extract the password hashes or whatever we want from them, and we don't affect the state of the target whatsoever. So this is probably a more effective way. So how do we go about doing that? Well, similar to the psexec command, we're going to use the mixin that we created and authenticate to the system. And then we want to run a Windows command. Well, there's a tool called reg.exe. It's in Server 2000. It's in Server 2012. So you'll likely not run into a system that doesn't have this tool. And with reg.exe, we can simply save a copy of the SAM, the system, and the security hive. Because remember, these are protected files. Even if you have system access, you may run into permission issues trying to copy these files unless you migrate into LSASS or do some other kind of black magic like that. But we make our registry hive copies. I choose to store them in the Windows temp directory. You can edit to store them somewhere else. We download them to our attacking machine, then we delete our copies. So again, the goal is leaving the system in the same state that it was when we started, but achieving the goal that we wanted to without uploading a shell. So we'll demo the module hopefully in just a little bit. I do just want to call out a couple folks that really helped out. I don't want to mispronounce the name, but the gentleman that wrote the cred dump suite, that code was very informational in writing the code that I use in my modules. And by the way, all the hash dumping functionality that's in Metasploit, if you take a look at that code, it's pretty easy to see that they just took the cred dump code from pwdump and converted it to Ruby. So big thanks to that guy. Carlos Perez, who wrote the smart hash dump module, that was really helpful to me. And then so the difference between the post modules in Metasploit it is that they require a library, a interpreter library, the client library. So effectively you have a live session and then you can interact with the live registry key. Well, since we're not doing that, since we have to interact with a static registry hive, I had to figure out how to alter that code to work with what we're trying to do. So Brandon Perry, who wrote the reg.rb file in the tools directory in Metasploit, that was really, really helpful. So thank you, Brandon. So the last thing I want to talk about before we try to jump into the demos is accessing all the hashes from the domain controller. So we're going to talk about the ntds.dit file, which is an extensible storage engine database on a domain controller. It contains a ton of information about Active Directory. There's a lot there that's, I think, still undiscovered, so we need more people kind of looking at this and playing with it. But basically, we're going to use known methodologies to acquire ntds.dit, get it on our attacking machine, and then extract the password hashes from it without affecting the domain controller. This is really cool because the current hash dump method in interpreters to dump the hashes if you have them interpreted on a domain controller is to migrate into LSASS. That works, but on a client's network, you may not want to be migrating to crucial processes on the domain controller. If something goes down, you could get into trouble. So the module that we created is called ntds grab, and again, using the psexec mixin, we can authenticate to the target, and we can use a series of Windows commands, and I'm going to read them out to you because I think that I apologize for the small font in the in the slide. But this is a known technique. There's documentation on this on the internet. We're going to use a Windows command called vssadmin, and what that's going to allow us to do is that's going to allow us to create a volume shadow copy. And inside the volume shadow copy, we now have an unprotected version of ntds.dit. Just like the SAM and the registry hives, this is a protected file. Even with system access, if you try to access it, you'll get access denied without, of course, migrating into LSASS and potentially threatening the state of the domain controller. So with the ntds.grab module, we can either create a brand new volume shadow copy, we can query the system for volume shadow copies that already exist, target a specific one, or we can give it the full absolute path, which is this like really, really long path name here. And then we can pull down ntds.dit. We pull down the system registry hive in the same manner that we did with the hash grab and cache grab modules. And then we can export the information. So the way that we have to do that, remember, ntds.dit, it's an extensible storage engine database. It's a binary compiled file, so if you try to open it up in a text editor, it just looks like garbage. So we're going to use a C library. It's an open source C library that you can get on. I think there's a Google code page. There's a link to it in the slide. But you pull down this libescdb, and then you can use some of the tools in there to extract the necessary tables from the ntds.dit database to actually get the password hashes. And again, this isn't anything that I created. These techniques have been around for a while, so we're just making use of them to achieve our goals without uploading a shell to the target. So with that said, with just a few minutes to go here, what I want to do is just kind of show you guys some of the stuff here. You guys see that? Well, of course not. Let me just change this here for you guys. There we go. Perfect. See if I can blow that up for you. There we go. So the first module that we talked about, psexec command, I'll just kind of show you what this looks like. We'll just run a simple ipconfig. We got a host of systems, so it's threaded. This is really cool. Run one command on a bunch of systems. We can see we get the output of ipconfig. I mentioned that a useful technique for this is to run the qwinsta command. So if we set the command to qwinsta, and if we run that, that's going to tell us the list of all the users and where they're logged in. Now, if you're running a spool file, this is going to be all on a text file that you can then grep for the users that are out there. We can see server admin, he's logged into this box 100. So if we just target that box real quick and change the command to query that user, we can see that this user, John Doe, is part of the domain admins group. So now we know which system to go after. So that's really helpful right there. Certainly at this point, I mean, I'm not against uploading shells. I would just upload an interpreter to that box, migrate into the process. But certainly another thing you could use is the cache grab module. So I'll show you what that looks like real quick. And we'll set that. So if we run that real quick, it's gonna authenticate. It's gonna create those registry hive copies. It's gonna pull them offline. This is the key part. It's gonna pull them onto our attacking machine and extract the hashes from them without affecting the target system. So now we have the MS cached password hash of the server admin. So we can run that on our dictionary file and maybe get lucky there. The hash grab module does the same thing, but it simply does the local hashes. And then the last thing that I'll show you is the NTDS grab module. And this one is also in the framework as well, so you guys can play with this. So a couple options real quick. By default, there's a create new VSC. It's set to false. So the default behavior is to leave the state of the domain controller as close to as it was before. It's just going to check and see if there are any volume shadow copies that exist. And then if there are, it's just going to use the most recent one and pull it down. You could set that to true, and then it'll just go ahead and create a brand new one. Or if you maybe use the psexec command to manually create a specific volume shadow copy, you could just provide the VSC path right here and do it that way. So we'll just go ahead and run this real quick. So it's going to check and see if a volume shadow copy exists. It found one. It's got this long path name to the volume shadow copy. It's going to pull down nts.dit. It's going to pull down the system registry hive, and it's going to store them in the MSF loot directory. So those two files are there. I'll show you what they look like. Just for usability, I'm just going to quickly rename these to, we'll name that NTDS. And we'll name that sys. So, as I mentioned, we're going to use the lib ESCDB library. And there's in the ESCDB tools, there is a file called ESCDB export. If we target NTDS, what it's going to do is it's going to export all the tables that are in this database. And as you can see, there's a lot of information here. We're only interested in this data table for getting hashes, but a lot of these tables are going to have juicy information. So we need a lot of people to kind of start looking at this stuff and see what we can find. So that's going to create a directory called ntds.export. If we cd into that directory, there's our data table. So created a tool in the Metasploit tools directory called ntds hash extract. If we run it without any arguments, it tells us just give me the data table, and then give me the system hive. There's already a tool called ntds extract that's worth mentioning that does all this stuff. I just wrote this Ruby tool because what I wanted, it dumps a lot of information, and I just wanted a list of John the Ripper friendly password hashes. So if we run that tool and target the data table and the system hive, if you run this on a production domain controller with several thousand users, go get a cup of coffee because this will take a while, but basically we now have all the password hashes to all the users on the database. Thank you. Appreciate that. So I hope we didn't run over on time here. Boy, this thing does not like Max. I know. Are you going to sort yourself out or what? There we go. So basically, just to kind of wrap it up and just kind of talk about, key topics here. Uploading binary shells, it's not something you should never do, but I think the mentality of the industry needs to change, that this isn't the first and kind of go-to choice. We can do a lot without uploading a shell, and that really gives us more options on the pen test. RPC is an unexplored black hole vortex. We need more people to look at this stuff because essentially you have access to the whole entire Windows API. You just got to figure out how to structure your NDR packet to get the parameters that the Microsoft function is accepting. There's already some great Metasploit modules in the framework that are doing this. I want to see more. I even believe that it's possible someone who was ambitious enough could go through the entire post modules directory, at least the Windows post modules, and I think probably every one of those modules could be rewritten to accomplish whatever task it does from a pre-exploitation standpoint on an auxiliary module without uploading anything to the target. Any questions? Go ahead. No, so it defaults to C $. Again, this is no different than the psexec exploit module. You have to have local administrator access for this to work because you're making a call to the create service function, which you need to be able to bind to the server control manager RPC handler, and you need to have local admin to do that. So it defaults to C $. You could use it with admin $ as well. Any other questions? Thank you guys. I really appreciate it.